Since this is a probability distribution, we know the sum of the probability must be equals to 1. So we write it as the sum from 0 as equal to 0 to 2, and sum of y is equals to 1 to 3, and write the function as the c bracket s plus y equals to 1. After that, we can just plug in the value for the sum of the y, and we will get the answer as 3s plus 6. And after that, we have to plug in the value of the each respective value of the s, which is s equals 0, 1, and 2. After that, we sum up the total of the each following answer, and we will get 27. Then we plug in into the original equation, which will get 27c equals to 1. And then move the 27 to the left right hand side, and we will get c equals to 1 over 27. After finding the c value, we now can construct the probability distribution table. Here's the table of the probability distribution. To find the marginal distribution of x and y, we have to calculate by using sum y for the function. And after we simplify, we get marginal s as 3s plus 6 over 27. After we plug in each value as s equals to 0, 1, and 2, we will get the answer. Here's the following answer. And for the margin y, we have to calculate the sum for the sum of s of the function. And after calculate, we get the marginal function of y as 3y plus 3 over 27. And we plug in the value for each respective value of y, which is y equals to 1, 2, and 3. To determine whether s and y are independent, we must satisfy the condition where the function f, y must be equals to product of the marginal s and marginal y. Since we already know the value of function 0, 1, which is equal to 1 over 27, now we can find the product of marginal by multiplying each value, and we will get 4 over 81. As we can see, the value of the function and product of marginal is not equal to each other, which means s and y are not independent. For the question D, the probability of y lesser than 3 given s equals to 2 can also be written as probability s equals to 2, y equals to 1, thus probability of s equals to y equals to over probability of s equals to 2. And then we'll just have to plug in the value for the each probability, and after calculating, we will get the answer as 7 over 12. For the question E, we have to find the mean of the s first, and after that we will get the mean as 11 over 9. And after that, we have to find the value of e bracket s squared, and we will get 19 over 9. To find the variance, we have to plug in into this formula, and we will get the answer as 50 over 81. For the y variance, similar as the S1, we have to calculate the value for the mean of y, and we will get 20 over 9. And then we have to calculate the value of e bracket y square, and we will get 50 over 9. And then we find the variance by plugging into this formula on the last line, and we will get 50 over 81. After that, we set the equation w equals to 4s squared plus 6y minus 2. And then we just plug in the value for each component, and we will get the answer as 178 over 9.
Find the value of k. So as we know, the total sum of probability is equal to 1. So the equation will be a double integration of 0 approaching k and 0 approaching 1 over 3 in bracket 3x squared plus xy dx dy. So for the first integration, we will make it respected to x, which from 0 approaching 1. So we get the answer is 1 plus 1y over 2. And for the second integration, we will make it respected to y, which 0 approaching k, and we will get k plus k square over 4 equal to 3. And then we're going to make it as a quadratic equation where we get k square plus 4k minus 12 equal to 0. And then we will get k is equal to 2 and k equal to negative 6. But since y is more than 0, so the answer for k is equal to 2. For question B, it asks to find the marginal density function for x and y. So for x, the equation will be 0 approaching 2 integrate 1 over 3 in bracket 3x squared plus xy dy. And then we will integrate it respected to y. So we will get the final answer, which is 2x squared plus 2 over 3x, where x is less than 1 but more than 0. Same goes for the marginal density function of y, where it's 0 approaching 1 over 3 in bracket 3x squared plus xy dx, where we'll integrate it respected to x. So we'll get the final answer is 1 over 3 plus y over 6, where y is more than 0 but less than 2. For C, it asks to determine whether x and y are independent. So as we know, to identify it is independent or not is f in bracket xy is equal to fx multiplied by fy. So f in bracket xy is equal to f squared plus xy over 3, while fx multiplied by fy is equal to 2 over 3x squared plus 2 over 9x plus x squared y over 3 plus xy over 9. So it didn't equal to each other, so I can conclude that x and y are not independent. For question D, it asks to find the mean and variance for p equal to 6x minus 3y plus 4. So first we need to find the mean for x and y, where for mean of x is integrate 0.1 x multiplied by fx, which is 2x squared plus 2 over 3x. So multiply, we get 2x cubed plus 2x squared over 3, and then we integrate it, and we will get the answer is 13 over 18 for mean for x. While for y is 0 approaching 2 integrate y multiplied by fy, where fy is 1 over 3 plus y over 6. We multiply by y, we get y over 3 plus y squared over 6, and then we integrate it respective to y, and then we get the answer mean for y is 10 over 9. So after we already find the mean for x and y, now we can find the mean for p. So as you can see in the equation, we can convert the value that we just calculate and put it in the equation. So we'll get the mean for p is equal to 5. And now to calculate the variance of p, but first we need to find ex squared and ey squared, since we need it to find the variance of x and y. So ex squared is equal to integrate 0 approaching 1 x squared multiplied by fx. So we get the answer will be 17 over 30, while for ey squared, which is 0 approaching 2 y squared multiplied by fy, and then we will get ey squared equal to 14 over 9. And after we already find ex squared and ey squared, we can finally calculate variance for x and y. So variance x, we can convert the value that we get to the equation, and we will get the answer as 73 over 1620. Same goes for variance y, where the answer is 26 over 81. After we already get the variance for x and y, now we need to find covariance. Since our variables are not independent, so we need to find covariance, but first we need to find e in bracket xy value first. So we need double integration 0 approaching 2 and 0 approaching 1, where xy is multiplied by 1 over 3 in bracket 3x squared plus xy dx over dy, and we make the first integration, which is respected to x, where we get 3y over 4 plus xy squared over 3, and then we make the second integration, which is respected to y, and we get the answer for e in bracket xy is equal to 43 over 54. After we already get e in bracket xy, now we can calculate covariance xy. So we can convert the value that we just calculate for exy, es, and ey into the equation, and we get the answer is equal to negative 1 over 162, where it states that the value of x and y have a negative relationship. So after we already have the value for variance x, variance y, and covariance xy, we can finally calculate the variance of p. So we can convert the value that we get to the equation. So then we get the variance for p is equal to 71 over 15.